In this problem, we are given that in triangle ABC, BC equals to 10, AC equals to 8. P is a moving point inside triangle ABC, and angle ACB equals to 30 degrees. Find the minimum value of 4AP plus 2BP plus 23CP. When you look at the question, first of all, you realize that these coefficients are hard to work with. So instead, you want to turn these coefficients into special ratios in geometry, because we realize there's square root 3. And square root 3, well, that appears in 30, 60, 90 right triangles. To get more of these special ratios, we can do this by trying to factor out the largest coefficient here. So this will become 4 times AP plus 2 over 4, which is 1/2, BP plus 3 divided by 4, which is square root 3 over 2, CP. So here, well, these are the ratios that we can get from a 30, 60, 90 right triangle. We have a 30 degree here, but we don't have a 60 degree. To get a 60 degree, we don't have to form the 30, 60, 90 right triangle inside of the triangle ABC. Instead, to get a 60 degree angle, we can do this by rotation. We can rotate triangle BPC by 60 degrees. We chose triangle BPC, not the other two triangles here, because BPC involves 2 of the 3 sides we need, BP and CP. So we can rotate it to get a new triangle. And then we can call these 2 points as D and E. And then we know that this angle here is 60 degrees. So basically what we done was rotate triangle BPC counterclockwise, because the direction of the rotation is from left to right. So rotate triangle BPC counterclockwise by 60 degrees to get triangle EDC. So by rotation, we'll get that triangle BPC is congruent to triangle EDC. From this congruence, we'll get that because we realize that we have a 60 degree angle here, and 60 degrees occurs in both right triangles and the equilateral triangle. But to form an equilateral triangle, we also need a pair of equal sides, which we can get from the congruent triangle. So from this congruent triangle here, we have PC equals to DC. And now since angle PCD equals to 60 degrees, so first of all, we realized that we had to connect PD to form the equilateral triangle here. So a helping line that we have to make will be to connect PD. We'll have triangle PCD is an equilateral triangle. And now from this equilateral triangle, well, an equilateral triangle is also an isosceles triangle. And an important property of isosceles triangles is called the 3-in-1 line. The 3-in-1 line is basically means that the height, the angle bisector, and the median of the isosceles triangle on a side coincides, meaning that they're the same line. So we can basically construct, we can call this point as M, because M will be the midpoint because of the median. So we can construct the 3-in-1 line. PM. And from this, we get the angle PMC, or to make it simpler, we just have PM is perpendicular to DC. And we also have angle CPM. Because of the angle bisector properties, it'll mean that angle CPM is half of angle CPD, which is 60 degrees from the equilateral triangle. So this will equal to 30 degrees. And also we have CM equals to DM. Now, we realize that we have to observe these ratios. AP right now does not seem to be part of this. However, since we know that by the rotation, here we have CE equals to 10. And then we also have CP equals to CD. So, and we have BP equals to DE. To get the 1/2 BP, well, 1/2 BP will equal to 1/2 DE. How do we get 1/2 DE? Well, DE is the side of the triangle, right? So 1/2 DE will correspond to the mid-segment of it. And the mid-segment can be constructed. We can call this point as N. So EN will equal to CN. MN will be the mid-segment because we know that M is the midpoint of CD. So we just construct the mid-segment. MN. So we will have MN equals to 1/2 DE equals to 1/2 BP. To get the square root 3 over 2 CP, well, square root 3 over 2 CP, in this case, by 30, 60, 90, right triangle, square root 3 over 2 CP will equal to PM. So basically our goal now will be to find AP plus PM plus MN. However, we want to find the minimum value of this. And the minimum value between 2 points is going to be the straight line through them. So the sum of these 3 line segments, to make sure that they're the smallest, we can just connect AN. So AN is shortest root. From A to N. And then to find it, well, first of all, we realize that we have angle PCD equal to 60 degrees here. However, by congruent triangle, angle PCB would equal to angle DCE. So meaning that this is also 60 degrees. So we have angle ACE will be 30 plus 60, which is going to be a right angle here. So we can find AN through the Pythagorean theorem. We have AC as 8. And then from the mid-segment, we also get that CN equals to EN equals to 1/2 times 10, which is 5. So the answer to this problem would be AN equals to square root of A squared plus 5 squared. And this equals to square root of 64 plus 25, which is square root of 89. So the answer will be 4 times AN, which is 4 square root 89. And that is the answer to this problem, 4 times square root of 89.